Before we begin, take a moment to slow down. Relax your shoulders. Unclench your jaw. Let your breathing become natural. There's nothing you need to do right now. Nowhere you need to rush. Just listen. This is a story about the future. About intelligence and about a question humanity is only beginning to understand. So sit back, focus, and let's begin. The forgotten women geniuses of history. Inventions hidden behind the shadows of revolutionary breakthroughs left in the shadow of their male colleagues. Part 1 of the inventions the world used without remembering the women who built them. There are some thefts committed with masks, and there are others committed with applause. A man stands at the podium. A company prints the patent. A laboratory publishes the result. A century passes, and by the time history starts asking where the idea really came from, the woman who built it has already been reduced to a footnote, a rumor, or a name spoken only by specialists. This is not a story about one forgotten genius. It is a story about a pattern, a machine that made paper bags possible at industrial scale, a blade that made driving through rain and snow survivable, a wartime communication concept that helped shape modern wireless systems, a treatment that gave people with Hansen's disease a path back to life outside isolation. Again and again the same thing happened. A woman solved a problem. The world kept the solution, and then too often it dimmed the name. One of the clearest early scenes in that story belongs to Margaret Knight. If you want to understand how history bears a woman's genius, begin not in a salon or a university, but in a factory. Knight was born in 1838 and became one of the great practical inventors of 19th century America. Britannica describes her as a prolific inventor, while the National Inventors Hall of Fame notes that she created a machine for making flat-bottom paper bags with a design that made mass production of the familiar square-bottom paper bag possible. That machine was operating by 1868, and after a legal fight she secured the patent rights. The legal fight matters because it tells you exactly what kind of world she was inventing inside. According to the Hall of Fame's account, a machinist named Charles Annan tried to steal Knight's design and argued in court that she could not possibly understand the machine's mechanical complexity. Knight answered not with outrage alone, but with evidence. Original drawings, working knowledge, and the fact that the machine was hers. She won. Even in victory, the insult remains frozen inside the story. A culture could use her machine more easily than it could believe in her mind. Picture the scene. A woman in the 19th century, surrounded by gears, paper, cutting edges, folding mechanisms, not speaking abstractly about invention, building it, understanding it, upthinking the men around her, then being told in effect that the machine looked too intelligent to belong to a woman. That is the first wound in this history, not only that women invented, but that they often had to prove they were even capable of having invented. Then there is Mary Anderson, whose insight was so practical that modern life makes it almost invisible. In the early 1900s, Anderson was riding through New York in bad weather when she noticed that trolley drivers had to stop, lean out, or open their windows to clear the windshield in sleet and snow. The National Inventors Hall of Fame says that moment led her to design a windshield clearing device operated from inside the vehicle, and she received U.S. Patent No. 743,801 in 1903. Britannica's invention chronology also places Mary Anderson and the windshield wiper in 1903. What makes Anderson's story so sharp is not just that she invented something useful. It is that the usefulness was immediate, obvious, and world-changing in everyday life, and still she was not treated as one of the central builders of modern mobility. The Hall of Fame notes that her design was the first effective windshield clearing device of its kind. Today the device feels inevitable, almost too ordinary to notice. That is often how women's inventions disappear. They become foundational so quickly that people stop asking who first imagined them. That kind of invisibility is different from dramatic exclusion. It is softer, cleaner, almost polite. No one has to hold a ceremony denying the inventor. The world simply absorbs the object, standardizes it, mass produces it, and moves on. The wiper keeps moving in the rain. The name stops moving with it. And then there is Hedy Lamarr, perhaps one of the most surreal examples in the whole archive of forgotten brilliance, because the disguise in her case was beauty itself. The public knew Lamarr as a film star, a glamorous Hollywood figure, one of the most photographed women of her era. Britannica notes that she was often cast as a femme fatale and only later gained recognition as the inventor of her radio communications device. The National Inventors Hall of Fame identifies her, with George Antheil, as the co-inventor of a frequency-hopping communication system designed to reduce the risk of jamming or detection in radio-controlled torpedoes. This is where the story turns almost cruelly theatrical, because the same society that loved looking at Lama did not know what to do with the fact that she could also think like an engineer. The wartime invention she developed with Antheil used rapidly changing radio frequencies to make interception and jamming harder. Hall of Fame and National WW2 Museum material both describe the design as frequency-hopping spread spectrum communication and connected to the later technological lineage of wireless systems. One National WW2 Museum program summary even states that the invention is used today in technologies such as Wi-Fi, Bluetooth, GPS, and other wireless systems. The glamorous actress walks into history. People assume they know what part she plays. Then decades later they discover she helped imagine one of the signal strategies behind the wireless age. That is not just neglect, it is misclassification. The culture looked at her and chose the wrong category, and once it did, her real contribution had to wait for a later century to catch up. Yet perhaps the saddest story in this first half belongs to Alice Ball, because in her case the theft came after death. Ball was a brilliant young chemist at the College of Hawaii. University of Hawaii sources say she became the first woman and first African American to earn a master's degree in chemistry there in 1915, then developed what became known as the Ball method, an injectable form of compounds derived from chomuga oil, which became the first effective treatment for Hansen's disease before sulfur drugs arrived decades later. The university notes that the method held patients in places such as Kalaupapa returned to their families after forced isolation. The American Chemical Society formally recognized the Ball method as a National Historic Chemical Landmark in 2026. But Alice Ball died in 1916 at just 24 years old, and after her death, her work was continued and publicly associated with Arthur Dean, president of the College of Hawaii. University of Hawaii can't say Dean published the findings without acknowledging Ball's key research and mass-produced the injectable treatment under the label Dean method. Only later did Harry Holman publicly restore her name, calling it the Ball method and making clear who had actually developed the process. That story should stop anyone cold, because there's something especially brutal about being erased after you are no longer alive to argue. Ball did not merely die young. She died before she could defend the ownership of her own breakthrough in the public record. Her treatment went on saving people. Her name did not travel with it at the same speed. The cure survived. The woman nearly vanished, and this is what links all of these women together, even though their fields were so different. Knight worked with paper bag machinery. Anderson worked with visibility and weather. Lamar worked with communication and anti-jamming logic. All worked with chemistry and disease. But in each case, the invention entered the world more easily than the inventor entered the historical imagination. The machine was useful. The blade was useful. The signal system was useful. The treatment was useful. The woman, too often, was inconvenient to the story men preferred to tell. That is why these histories feel less like isolated injustices and more like a system with recurring instincts. Women were welcomed as labor, inspiration, assistants, muses, wives, assistants again, and sometimes public symbols. But when they appeared as original technical minds, institutions often hesitated, doubted, minimized, or delayed recognition. Sometimes the exclusion was open, like the courtroom insult aimed at Margaret Knight. Sometimes it was subtler, like the public's inability to imagine Hedy Lamarr as an inventor. Sometimes it was almost administrative, like the relabeling of Alice Ball's work after her death. And once you see the pattern, the first half of modern life begins to look different. The rag in your hand is not neutral. The windshield in the rain is not neutral. The wireless signal in the air is not neutral. The medical breakthrough in the archive is not neutral. They are all part of a world that was often built by women whose names were treated as optional details. So part 1 ends not with a list of inventions, but with a corridor of shadows. A factory floor where Margaret Knight fights for authorship. A snow streak trolley where Mary Anderson sees what every man has missed. A Hollywood star sketching the logic of secure wireless communication. A young chemist in Hawaii giving desperate patients their first real chance at treatment only to lose the credit after death. And behind all of them hangs the same hard truth history did not always forget these women by accident. Sometimes it used their ideas while quietly stepping around their names. Part 2 of the discoveries that changed science while other names took the prize. If Part 1 belongs to invention, Part 2 belongs to revelation. Not machines for daily life, but discoveries so large they changed how humanity understood life, matter, motion, and the universe itself. And here the injustice often becomes even sharper, because in science recognition is not only memory, it is legitimacy, funding, authority, the right to become the face of truth. When that face is given to someone else, the loss is not symbolic. It alters who the next generation imagines a genius can be. Begin with Rosalind Franklin. Britannica states that Franklin discovered the density of DNA and, more importantly, established that the molecule existed in a helical conformation. Her X-ray diffraction work at King's College London laid the foundation for Watson and Crick's double helix model in 1953. Nobel's own historical storytelling now explicitly notes that Franklin's X-ray image of DNA and other findings influenced Francis Crick, James Watson, and Maurice Wilkins in their work. Many have argued that she never received sufficient credit. This story is famous now, but fame should not be confused with justice. Because when the Nobel Prize in Physiology or Medicine was awarded in 1962, it went to Watson, Crick, and Wilkins. Franklin had died in 1958, which meant she was ineligible under Nobel rules for a posthumous award. But the dispute over credit did not arise only because of the Nobel's posthumous rule. It also arose because her work, especially the famous Photo 51 and the data surrounding it, became part of the pathway to the double helix, while her position in the public myth of discovery remained too small for too long. Nobel's own later reflections and historical commentary make clear that Franklin's findings were central to the story. Imagine what that means at the level of memory. One of the most important scientific images in modern history. A researcher whose work helped unlock it. 3 men standing in the canonical version of the story, and the woman whose data helped make the structure visible entering public memory later as correction. Not absent, but delayed. And delay is one of history's favourite instruments of injustice. Then there is Lise Meitner, whose exclusion remains one of the most painful episodes in 20th century physics. Britannica says that after Otto Hahn and Fritz Strassmann showed that barium appears when uranium is bombarded with neutrons, Meitner, working with her nephew Otto Fischer, explained the physical meaning of the result, and in January 1939 proposed the term fission for the process. Britannica and Nobel's own material both note the later controversy. Hahn received the 1944 Nobel Prize in Chemistry, while many argued that Meitner merited a share of the prize. Nobel's fact page on Hahn explicitly states that Meitner and Frisch proved that the uranium nucleus had been split. The emotional brutality of Meitner's story lies in how close she was to the centre of the discovery and how far she stood from the final public reward. She had worked with Hahn for decades. She had fled Nazi persecution. She was the one who, with Frisch, supplied the conceptual breakthrough that turned baffling chemistry into a new physics of split nuclei. And yet history, in one of its coldest moments, gave the greatest formal honour to the man who remained standing in the laboratory frame while the woman who interpreted the phenomenon from exile was left outside the Nobel citation. Later recognition came, including the shared Enrico Fermi Award in 1966 with Hahn and Strassmann, but that later gesture never fully erased the original omission. Now move from nuclear physics to particle physics, and the pattern returns in another form with Jiansheng Wu. Britannica identifies Wu as the physicist who provided the first experimental proof that parity conservation does not hold in weak interactions. Britannica's Women in Science timeline likewise highlights her as the First Lady of Physics for this achievement. Yet the Nobel Prize in Physics in 1957 went to Tsundao Li and Chen-Ning Yang, whose theoretical proposal Wu had tested experimentally. Britannica's educational summary states the omission bluntly. Wu's work was essential in proving the theory, but the Nobel went to Li and Yan. This is one of the clearest examples of how experimental brilliance can be treated as secondary to theoretical fame, especially when the experimentalist is a woman. The theory says something radical. The experiment proves whether nature agrees. Without the experiment, the theory is only elegance. Wu performed the experiment that changed physics. The universe itself answered through her apparatus. But when the medals were handed out, the symbolic centre of the achievement moved elsewhere. That pattern should feel familiar by now. The woman is indispensable to the discovery. yet somehow not central enough to the public mythology built around it. And then there are the women now remembered as hidden figures, a phrase that became famous because it was true. NASA's official biography of Katherine Johnson says that in 1960 she co-authored a technical report on orbital flight equations, and it was the first time a woman in the Flight Research Division received credit as an author of a research report. NASA also states that Johnson's calculations were essential to Project Mercury, that John Glenn specifically asked for her to verify the electronic computer's numbers before his orbital mission, and that she later contributed to Apollo Air work as well. Johnson's story is slightly different from Franklin's or Meitner's because the shadow she fought was not just one male colleague. It was an entire system of institutional invisibility built around race, gender, and hierarchy. NASA's own recent coverage still frames Johnson, Dorothy Vaughan, Mary Jackson, and Christine Dodden as figures whose work was essential but long under-recognized, which is why the Congressional Gold Medals awarded in 2024 mattered symbolically as much as historically. What these women had in common was not only intelligence, it was proximity to great historical turning points without automatic admission into their official center. Franklin stood beside the structure of DNA. Meitner stood beside nuclear fission. We stood beside the breakdown of parity. Johnson stood beside the mathematics of human spaceflight. The discoverers changed the world. The world changed more slowly in learning how to speak their names. And this is where the title becomes larger than biography. Because a women genius is history forgot is not merely a phrase about the past. It is a warning about how historical memory is manufactured. People often imagine memory as a meritocracy. The best idea wins. The clearest proof survives. The greatest mind is eventually recognized. But that is not how it works. Archives, prizes, institutions, publicity, prejudice, timing, death, status, nationality, and gender all shape who becomes the face of a breakthrough. In some cases, as with Alice Bull or Margaret Knight, the fight is over patents and practical credit. In others, as with Franklin, Meitner, Wu, and Johnson, the fight is over whose name becomes attached to the discovery when textbooks compress complexity into a single line. That compression is deadly, because once history becomes simple, it often becomes male. One genius, one photograph, one prize, one founding father of the field. The women remain nearby in the story, but nearby is not the same as central. Nearby means cited after the fact. Nearby means rediscovered. Nearby means the audience lends their names as an act of correction instead of inheritance. And yet perhaps the most moving part of all this is that the work itself refused to stay buried. The bag machine kept making bags. The windshield wiper kept clearing storms. Spread spectrum ideas kept evolving into the wireless world. The ball method kept treating patients. Photo 51 kept haunting the history of DNA. Fission kept remaking geopolitics. Parity violation kept standing as one of modern physics' great shocks. Orbital trajectories kept carrying humans beyond Earth. The inventions and discoverers endured even when the names attached to them within, delayed, or bent out of shape. That is why these stories still matter in voiceover, in history, in classrooms, and in culture. They are not only moral corrections. They are structural revelations. They show how genius can be present, productive, world-changing, and still be treated as peripheral if the surrounding culture prefers a different face for brilliance. So this story ends not ambitious alone, but in a kind of reckoning. A courtroom where Margaret Knight proves she understands her own machine better than the man trying to steal it. A trolley car where Mary Anderson sees what modern transport is missing. A chemist in Hawaii whose treatment works while another man's name tries to cover it. A film star whose mind outruns the category assigned to her face. A crystallographer whose image helps reveal life structure. A physicist in exile who gives a name to the splitting of the atom. An experimental genius whose proof changes physics while others collect the Nobel. A black mathematician whose equations help carry the United States into orbit while the institution around her is only beginning to admit she belongs in the room. History did not always forget these women because their work was small. It forgot them because their work was large enough to be taken. And perhaps that is the final truth behind the shadows. The world was changed by women whose names were often treated as optional. The inventions stayed. The discoverers stayed. The future stayed. Only the credit tried to move on without them.